Hello everyone and welcome back. In this video we need to specifically talk about what latitude is, and we said in general latitude is going to be able to allow us to specify how far north or south of the equator we are. So let's go ahead and begin with that definition of latitude. Importantly, latitude is an angular measurement from the equator to the north or south pole. So here we have a representation of the Earth, the equator, and then we are going to give a measurement of how far north or how far south we are. The equator is of course 0 degrees latitude. When you're at the equator, you are of course no distance north or south of it. Then latitude goes all the way to 90 degrees north and 90 degrees south. At 90 degrees north, you're at the North Pole. At 90 degrees south, you are at the South Pole. I would like to draw your attention to this word angular here. Latitude is an angular measurement. And I would like for you to connect the unit of measurement that we measure latitude in to the unit of measurement that we typically measure angles in. Of course, you measure angles in degrees. You remember that from basic geometry. So when you think of measuring latitude, and you think that latitude is an angular measurement, then it makes a lot of sense that we would be measuring it in degrees, because actually when you give a specification of latitude, you are actually specifying an angle. And I want to get into that in more detail in just a moment. But first, why would we use angles to measure latitude anyway? We actually use angles to measure longitude as well, so we have an entire angular coordinate system for specifying location on the planet. Why do we do that anyway? Well, most people are familiar with Cartesian grid coordinates. Much of middle school and high school mathematics classes are based around Cartesian grids. You know, you have an x-coordinate and a y-coordinate, and so you take the x-coordinate and go over so many, and then the y-coordinate and go up or down so many, and then you're able to specify a location. And that works extremely well for specifying location in two-dimensional space. A Cartesian grid is based on a plane. How do you specify location on a plane? So if it actually were the case that the world were flat, then we could use a Cartesian grid for specifying location. But it's not. The Earth is spherical, so we have to start thinking about coordinates in three-dimensional space. We're not just trying to specify coordinates on something flat, we're trying to specify coordinates on something round. And so when you're operating in three-dimensional space like that, the system that we specify location with becomes based on angles. So let's take a look at this. This is a circle here, but it's representing a cutaway of the Earth. So I just took the Earth and I cut it in half right from the North Pole down to the South Pole. So that's what you're looking at here. So you can see we do have the North Pole and the South Pole, and then the equator is right across the center of the Earth. So whenever we give a latitude, we're actually giving an angular measurement from the equator all the way up to wherever it is that we're specifying the location of. So let's take a look at that concerning the North Pole. So we have the equator right here, and then there's also a line that goes from the center of the Earth all the way up to the North Pole. So when I have the equator line, and then I have the line going up to the North Pole, I hope that you see that those two lines form a 90-degree angle when you put them together. And so when you're reporting latitude, you're reporting the angle that is formed by the equator and the line going to the position that you're looking to specify. So if you're looking to specify the North Pole, what exactly is the angular measurement from the equator all the way to the North Pole? Well, that's a 90-degree angle. Therefore, the North Pole is at 90 degrees, and we specify direction, 90 degrees north. If we're going north of the equator, we specify that with north. So if you go up to 90 degrees north, then you're at the North Pole. And so when you're looking at something like this, with this cutaway of the Earth, I hope you realize why there can't be anything higher than 90 degrees north. You can't do any angle that's greater than this 90-degree angle, because once you go past 90 degrees and you start to make what would be an obtuse angle, here in this depiction, well, take a look at the reverse of the obtuse angle. Well, the reverse of the obtuse angle would be an acute angle, and so we just use that measurement to specify latitude. We don't go past 90 degrees and then start going down the other side of the Earth. We just know that on the other side of the Earth, if, for example, you did try to go to 100 degrees north, well, that's 10 degrees past 90, and what you would be at would be 80 degrees north. and so we just specify that as 80 degrees north. Here is the same situation but set up for the South Pole. So also an angular measurement from the equator to the line that goes to the South Pole. That also creates a 90-degree angle, and that's why the highest latitude in the southern hemisphere is 90 degrees south. So here's a slightly different setup, but it's showing basically the same thing. So rather than going up to the point of the North Pole, we're trying to specify something at 45 degrees north. So if you were to measure the angle from the equator and then you went up to a 45-degree angle, you would just go out to the surface of the Earth at the point at which that angle, this line of this angle, touches the surface of the Earth. And then everything that touches that part of the Earth is 45 degrees north. You can think of this spinning in 3 dimensions. So everywhere where that line of the angle goes up and touches the surface of the Earth all the way around the sphere, we call that 45 degrees north. Likewise, you measure a 45-degree angle down south, and then you have 45 degrees south everywhere where that line segment touches the Earth all the way around in a sphere. Here is an example with 20 degrees north, and here is an example with 20 degrees south. So I hope after this, if you hadn't already understood the idea of latitude as an angular measurement, that when you look at this, you do realize why latitude is specified in degrees. It's because any specification of latitude is specifying a particular angle. Here is an attempt at a 3-dimensional depiction of the spherical Earth with this section of the Earth cut away. And so here you can see in sort of a 3-dimensional drawing why you've got this angle that goes from the equator to the center of the Earth, and if it's a 50-degree angle that comes up, then everywhere where that angle touches the surface of the Earth becomes 50 degrees north in this example. It's pretty common to show a cutaway like this that also explains latitude. Here the Earth kind of looks like an orange that's been cut in half. This allows you to see all of the lines that create these lines of latitude. So you can see that if you were to follow this angle right here, then everything around the surface of the Earth would be 30 degrees north, 30 degrees south, and then here's 60 degrees north, 60 degrees south, and then once again you can see that once you are at the right angle, then you are at the highest possible latitude, 90 degrees north and 90 degrees south. I would like to point out a few characteristics of lines of latitude. First of all, lines of latitude are equidistant. A degree of latitude is approximately 69 miles. So if you go north or south from any line of latitude about 69 miles, then you will get to the next line of latitude. Lines of latitude are often called parallels. Sometimes you hear them called a line of latitude. Sometimes people talk about parallels. The reason that lines of latitude are known as parallels is because of this reason. Because each one of them is equidistant, they are parallel to each other. Lines of latitude are parallel to one another, and therefore you can call them parallels. And now I would like to draw your attention to a few important lines of latitude, or parallels, that everyone in geography or geographic information systems should know. The first of these is the equator, which is at 0 degrees. And that's not 0 degrees north or south, there's no direction there. The equator is just 0 degrees. When you go higher in latitude, you get to 23.5 degrees north, and also 23.5 degrees south. These are very important lines because they specify the tropics. 23.5 degrees north is the Tropic of Cancer, 23.5 degrees south is the Tropic of Capricorn. As you continually go higher in latitude, you get to 66.5 degrees north, which is the Arctic Circle, and then 66.5 degrees south, which is the Antarctic Circle. Continuing, of course, you get to 90 degrees north and 90 degrees south, which are the North Pole and the South Pole. The Arctic Circle, the Tropic of Cancer, the Tropic of Capricorn, and the Antarctic Circle are very important lines of latitude for astronomical reasons. And I talk about these more when we talk about astronomical geography. I would like to point out a feature of the terminology as I've been using it. It's very common to talk about higher latitudes and lower latitudes, and so it's also very important to understand what it means for something to be a high latitude or a low latitude. High latitude and low latitude are measured from the equator in both directions. So both the North Pole and the South Pole are high latitudes. They're the highest latitude possible. And so generally speaking, areas around the North Pole and around the South Pole are known as the high latitudes. The low latitudes are found around the equator. So around the middle of the Earth, running around the Earth in a band, you find the low latitudes. So high latitude and low latitude correspond to the number of degrees there are. High latitudes, higher degrees; lower latitudes, smaller angles, smaller degrees. So keep that in mind when people talk about high and low latitudes. Some people erroneously think that high latitudes are northern latitudes and lower latitudes are southern latitudes, but that's not true at all. Both the northern and the southern hemisphere have high latitudes as you approach the poles, and both the northern and the southern hemisphere have low latitudes when you approach the equator. Okay, so now that we have an idea of what latitude is, it's time for us to talk about how you can determine what your latitude is. So the first part in determining your position on the planet would be the determination of your latitude. And actually, people have been able to do this since ancient times. So let's take a look at the determination of latitude next.